AdamDunkels, and I'm a senior researcher here at SIX. I've been that for 10 years when I started with my master's thesis 10 years ago.
Well, you've just written a book about interconnecting smart objects with IP, and that sort of addresses the whole theme of the Internet of Things.
Right.
I understand that we, meaning people, are now a minority of those using the Internet. Is that true?
Well, I think that we may see that at least in the future. For now, we have, I think the latest count that I saw was that we have about 4 billion devices connected to the Internet, which is still fewer than the number of people on Earth, but it will still mean, since we don't cover all the people by Internet connectivity, it still means that a great number of systems are not people-centric, but are actually machines that are connected to other machines.
So what does that mean? I mean, are we moving toward Skynet in the Terminator series, or are we moving to a world where there's going to be more data that just moves between machines and we have no idea what they're doing?
Yeah, I think that the Skynet predictions are not what we're seeing now. I think that the idea of having machines that autonomously work together to some evil goal hasn't really, we don't see any steps towards that. Rather, what we see is that people are actually using this data that these machines or devices are creating instead of machines using it. So it's more still very people-centric, but we have much more data, as you said.
So basically at this point the people are reading the machines talking about themselves, saying I'm about to break down, or I need more spare parts, or I've just stopped, yeah. And people have to make the decisions.
Right.
In terms of managing large parks, large groups of machines, factories and stuff, where do you see the future? Do you see the opportunities for writing software so that the whole factory can run autonomously, or?
I definitely see the future is going there towards much more software-centric systems where we have data coming in from different sensors, different sources that needs to be processed by software and through software. And what we see is that as we have more and more computers, we definitely will see more and more software. So I think that the future for software and software development here is really bright, seeing that we have much more computers everywhere.
And what directions, if you're a software developer in the Baltics or Latvia and you're thinking of, finding a business opportunity in this Internet of connected machines, what direction should people be looking in? Right.
I think that the greatest problem for the future in this area is data. We will be collecting sensor data from anything from temperature sensors, humidity sensors, kind of physical, direct physical environment sensors, but also to much more complex sensors that monitor indoor environments, see where people are being and staying, to monitor the homes and offices so that the heating and the lighting can be...
These are smart buildings now.
Yeah, smart buildings, we have smart cities, we have factories. We see this really going into everyday society. So that, and all this data needs to be reprocessed, and someone needs to make something useful from the data. And I think this is the grand challenge for, let's say, the majority of developers in this area, is to figure out how to use this data in a useful way.
Does that mean pulling the data together, analyzing it, and putting it on some kind of a dashboard on the decision maker's desk, or does that mean writing a meta program that makes decisions instead of a person?
Well, I think both, and I think just this presentation of data is one of those things where we are still free to experiment. We will be using cell phones or smartphones to interact with data, or will it be completely autonomous in some sense, where we just give directions as the operator and let a computer software help us making the decisions? Well, I think this is one of the things that we haven't really figured out. We don't really know where this is going. But I think for, let's say, the development of software is really going towards this. And I think that for an enterprising software developer, there is a lot to do here, regardless of where it's going.
Well, what's going on, for instance, you're probably more familiar with the entrepreneurial scene here in Sweden, maybe other places you visited. What is going on? What are people doing?
Well, I think people are working in all layers, down from the lowest, let's say the physical, the sensors and picking up the data, to the communication layer, where we take the data from its physical location, move it to somewhere else. We have people working in the hardware and the software there, and all the way up towards really making this useful and presentational issues, so that you can get it on a phone, you can get it on a website. So I think at this point we'll see, it hasn't crystallized so that we see certain aspects being much more, let's say, fruitful than others at this point. It's still very open. But we've been seeing, let's say for the past 5 years or so, we've seen a lot of work being done at the lower layers, just getting this to work, the technology behind this.
Well, the lower layers involve designing and prototyping and building physical equipment, and that's can be capital intensive.
Yeah.
So if you're talking about a country that is not got it's a very little risk capital, very little venture capital like Latvia, then where do you see a bigger opportunity there on the software side?
Yeah, definitely. And I think that, well, what we've been seeing for the past few years is that we have the opportunity of using the cloud infrastructures, the various cloud infrastructures out there, to do much more data-intensive software without having to invest that much into actual hardware, which means that there is a chance here to do something with very little investment, initial investment, to get something started by just using software. And I think that is an opportunity.
And that's something that people, I mean, Latvia has a good reputation for mathematics and people who do algorithms, and they design the grade business process description language, and you might be familiar with some of that.
Yeah.
So do you see that the chance that the programming and developer community in Latvia could take a significant role in this?
Yeah, certainly, because the hardware side is becoming commoditized, which means that you can pretty much pick that up at any place. At the same time, you have the kind of infrastructure, like the cloud infrastructure, is also becoming commoditized. So you can actually pick that up from various places as well. So which means that the thing that holds this together is the software. And that is the place by having a background with software development and algorithms, it really allows you to take that part in the market.
Your ancestry is from Latvia. Have you been over to see people in the software community there at all? Or?
Unfortunately not, no. I've actually never been to Latvia.
Okay. Well, there's always a chance.
Yeah.
Sort of looking deeper into the future, are we going to reach a saturation point at which the amount of data that is generated, the more sensors we put out, the more we know, what our coffee cup is doing, the more we know where the cat is, the more we know what the temperature is in our summer house and all that stuff. Are we not risking generating more data than the computing capacity the world can deal with, or is that not a problem?
Well, I think that the computing capacity is growing so fast that I think it's hard for anything to keep up with it. So I think that we'll have enough computer capacity to just the raw computation for this data. The question is, what data is useful, and how do we make that out of all this noise that's going to be generated? I think that's the real challenge. I don't think the challenge is finding the transistors to do the job, but to figure out what the job is. And that is the challenge, to make this data useful.
Sort of getting back to some of the software trends, one of the things that is a hot topic, and it's going to be probably a hot topic again at, say, a major forum like IBM's Information on Demand, that is analytics and predictive analytics. Do you see a future for predictive analytics, especially where we're going to have almost all of the critical systems in a society running, you know, their data through this Internet of Things. Is that going to be important to tell us something's happening that may stop the metro in a week? Something's happening that may break down something else?
Yeah, I must say I'm not familiar with the predictive analytics, but I think that this is where what we've seen in industrial automation is where people are using this technology right now, is to predict maintenance before things break. So you can for instance have a vibration sensor on a machine that vibrates, and this vibration sensor would pick up anomalies in this vibration that could indicate something is about to break. So you can shut the machine down at night when it's not being used, and you can fix it, and then turn it on, and it's going to be back up instead of having it break.
But the critical knowledge there is knowing what vibration pattern means it will break, and that is what you were getting at, the software, the sort of smart software. Yeah. Because, you know, having a device there that says, yeah, the thing is vibrating isn't telling you very much.
Of course, yeah. So certainly there is definitely an element of well, analyzing this data and understanding what it means.
You're here in a sort of academic environment, and I think you probably meet up with students. And what would you tell a student who wants to be a developer or wants to work in the Internet of Things, since this is the future? What kind of areas of mathematics, what kind of areas of software should they study in order to become competent in this?
Right. I think for the future, one of the most crucial areas is large-scale systems, and that includes a wide variety of topics. Anything from, let's say, databases to computer systems and distributed systems, and down to just writing software. I'm talking about things like, well, practical side, things like MapReduce and software techniques for large-scale systems management. And of course, down to the actual software running on each and every device out there, which is small-scale systems instead of large-scale systems. So I think that these two, but for the future, I would say that large-scale systems will definitely be out there, and will be even more of those. So working in this area would mean both the small-scale, but also the large-scale. And my best guess would be that large-scale systems is the future there.
Yeah, so this would be learning the mathematics and the the means of analyzing complex structures, and all that mathematics and that is the future. And once you have that down, you probably will know what to do.
Yeah, definitely. Then you have something. You have your tool set to use for whatever these systems will be in the future. Once you have the understanding and knowledge of how to analyze and deal with large-scale systems, definitely.
So somebody who studies that in Latvia and who has the access for, what is it now, I don't know, $1 an hour to the Amazon cloud, and the algorithms could develop the next big thing, the next killer app.
Sure.
It's just there just as well as anywhere else.
Definitely, yeah. And I think that we'll see also, at this point we have large companies starting by, let's say, IBM, Microsoft, Google. They've all grown up in their own time, right? And we're still waiting for the next big company to emerge. And, well, we really don't know where it's going to originate from. And since we have a much more level playing field with things like Amazon's cloud infrastructure, it means that it could come from Latvia, it could come from Sweden, it could just about come from anywhere where we have people with the right skills and the entrepreneurial attitude, definitely.